Yeah, good morning, students. It's my pleasure to introduce this new topic on collision resolution techniques. So, in previous CDT, we discussed about the open addressing collision resolution methods, four different types of techniques like linear probing, quadratic probing, double hashing, and rehashing. So, which are classified under closed hashing techniques. Now, in this particular CDT, we would like to discuss about the uh, separate chaining mechanism, which is also another important collision resolution technique. And this particular method is called it as the open hashing technique. Okay, so now I would like to share my screen. So, hope my screen is visible to you. So, this is week 13, lecture 3, collision resolution techniques by separate chaining. So summary of the previous CTT is that we had a discussion on open addressing techniques. So double hashing and rehashing we discussed in the previous CTT. So double hashing will uses two different hash functions. So one hash function is used for mapping the key into the hash table index. If a collision is found, then another hash function we are using for resolving of that particular collision. So independent hash function we are using, so that is the reason here double hashing we can call it as. So when the hash table becomes nearly full, the number of collisions increases, thereby degrading the performance of this insertion and deletion operations on hashing table. So in such cases, a better option is to create a new hash table with size double of the original hash table, and then all the entries in the original hash table will then have to be moved to the new hash table by making use of a new hash function. That is called it as a rehashing technique. So even it is easy for implementation, but as per performance point of view, or it is going to take more memory size. So the today's CDT objectives are that we are going to discuss about the collision resolution technique by separate chaining method, so which is also called it as open hashing technique. So upon completion of this CDT, students are able to solve the problems on collision resolution technique using separate chaining method. Okay, so in chaining method, each location in a hash table stores a pointer to a linked list. Okay, each location in the hash table is going to store a pointer to a linked list that contains all the keys that are mapped or hashed to that location in the hash table. That is, if a hash function maps a key value to location 1 in the hash table, then all the keys which are mapped to that particular location 1 will be stored with a linked list. Okay, so if there are no key values hashed to a particular location in the hash table, then that location contains a null value. Fine. So if you see in this particular diagram, so we have a universe of keys are there here, k1, k2, k3, etc. These are different keys you want to map into a hash table of size m is equal to 10 if you take it as hash table of size 10 if you take it as. So initially 0 to 9 we are going to take, these are the index values of the hash table, and initially all are stored with null values. So once this key k1 is mapped to this 0th index, then we are going to create a node, and in this particular node, this is a node structure which is same as the single linked list node structure. So we are storing the key k1 and the link field here is null, and here the pointer we are storing this address of this particular node. So like this here, if another key k3 is mapped to the second index location, now we are storing, creating a new node, and then we are establishing a pointer to this new node k3. So if another key k2 and k6 are mapping to the third index location, then we are creating a single linked list with these two nodes. Fine. So the last node in the single linked list is pointing to a null. So like this, if there are no keys mapped to this 4 5 6, so it is having only null pointers. So when we are mapping the key k4 to the 7th index, we are creating a node and we are storing that key into that, and we are changing the pointer null to this particular node. So like this, index 9 is pointing to this k5 and as well as k7 here. So this is what a single linked list we have created, and these are the two keys k5 and k7 mapped to the same index location. So this is what we are calling it as every index location in this hash table is a pointer pointing to the address of a single linked list. If there are no nodes mapped to that particular location, that particular node in the hash table is going to be stored with the null. This is what we are calling it as a separate chaining mechanism. So this is an example you can consider here. Uh, Insert these following keys into a chained hash table of 9 memory locations. So use h of k equal to k mod m is the hash function. So in this case, m is equal to 9 we have given. Initially the hash table can be given as 0 to 8. 0 to 8 all are nulls. This is the initial hash table. Fine. So once you take in step 1 key equal to 7, that is the first key value you want to map into this hash table. So you apply this hash function h of k equal to k mod 9, so which is equal to 7. So create a linked list for location 7 and store the key value 7 in it, and as it only have this particular node. Fine. So key 24. So step 2, you have to map to the 24 key value h of k equal 24 mod 9. So we are going to get it as a 6. So create a linked list for the location 6 and store the key value 24 into it as it's only one node. Fine. So like this, you are going to create a linked list for storing these 7 and 24 in the respective locations. So for remaining keys, key equal to 18, so you are going to create a linked list for 0th index, key equal to 52, it is mapped to the 7th location. So 7th location already we have a linked list, so we have to insert a node 52 at the end of this node 7. Fine. So you have to traverse this list and you create a node and a link, establish this link to this list. Fine. So like this, you are creating a single linked list such that all the nodes which are mapped to this 0th index, so with that you are creating a single linked list. Fine. So like this. So step 7 and step 8 also similar to that. Key 11 is mapped to second index location. Key 23 is mapped to fifth location index in the hash table. So after inserting all the key values, now this is the final hash table which is created by making use of a chaining method, separate chaining method. Fine. So this is what the reflections part. What is meant by separate chaining method? So if you are not able to answer this question, please watch the video from the beginning. Okay. And the lecture outcomes are revisited here. After completion of the session, students will able to solve the problems using collision resolution technique, called it as a chaining method or a separate chaining method. So in summary of these two CDT is that in chaining, each location in the hash table stores a pointer to a list of nodes which are mapped to that particular location. So while the cost of inserting a key in a chained hash table is order of 1, for deleting and searching a value, it is order of m, where m is the number of elements in the list of that particular location. So however, in the worst case, searching for a value may take a running time of big O of n, it may take that. Okay, so this is what the summary of this today's session is. And then lecture level practice problem is that you are supposed to ask the question like this in the examination: differentiate open hashing from closed hashing techniques. Okay, so this is further readings on this particular topic. Fine. So thank you and all.